Hi everyone, it's week 13 and that means it's review week, so I'm going to do 3 problems drawn from chapter 7, 8, and 9 this time. In video A here I'm going to do problem 7.41 found on page 305 and problem 8.74 found on page 341. They are related, same problem, just looking at it in a different way. In this problem we're looking at expense reports. How much should it cost to travel to Moscow in Russia? Now, I've been to Moscow in Russia, and I tell you right now, it's a lot more than $500. It's an expensive city. But nonetheless, someone has done a study by sampling 35 expense reports and calculated the average and found it to be $538. We're also told that the population standard deviation, sigma, is actually $40. Now, this is chapter 7, so we don't know any better yet. We haven't learned in chapter 8 and 9 about t-distributions and how to handle things when we don't know the true standard deviation, which is normally the case. But in this chapter we'll play dumb and accept the fact that the standard deviation is 40. I think we're also told it's a normal distribution. But nonetheless, the boss wants to know what's the probability of getting an average of 538 if the population's the true average is $500. Now, so what we're going to do is to use the sample data to validate in a way the $500 assumption. This is very much like what we're doing in chapter 9, but of course we're in chapter 7, so again we have to put the blinders on. Now let me just show you one chart here. When we look at the sample data, chart to come over here. The sample data says that the assumption is that the mean is $500 and the standard deviation is $40. Now, we know with 95% certainty that the range of individual expense reports will fall between 2 standard deviations less than 500, that's 420, somewhere over in here, and 2 deviations the other side of the mean, which would be 580. So 95% of the expense reports that get turned in ought to be in this range of 420 to 580 if the mean is actually 500. But that's not what we are really studying here. We're interested in the range of averages. If we take 35 expense reports time and time again, every time we take that average, we should get an average, take that sample, we should get an average that falls in a much narrower range. In fact, the range of sample means will look something like this, where the mean is 500, but now the standard deviation is much less. We know that it's much less because we're averaging together the outliers when we do an average, and their influence is greatly reduced. So the range of possible averages will be much narrower. In fact, we know that 6.76 is equal to, I'll call this S, the sample standard deviation, is equal to the population standard deviation of 40 divided by the square root of 35, or 6.76. That's where the number on that chart came from, of course. Now the question is, what's the probability of getting an average of 538 if the true mean is 500? Well, we know we need a z value. So we're going to take the sample value of 538 and subtract 500 from it and divide that by the standard deviation. That says our sample of 538 lies I'm going to get the wrong chart here. I'll get this chart out, the normal standard deviation chart. The standardized normal curve. The sample we drew is 5.62 standard deviations to the right of the assumed mean of 500. That's way out here, or way off the chart, so we know the probability is going to be really low. But we can calculate it. We can't use table 6.1, it ends at 3.99. So we'll have to use norm standard distribution and plug in the z-value and get, ooh, wait a minute, the Excel on the table 6.1 gives us the area to the left of the point we're interested in. We're really interested in the area out here on the tail, which you can hardly see. So I have to subtract that from 1, don't I? So I'll say 1 minus. And that gives us 9.5 times 10 to the minus 9th. That's 9.5 billionth of a unit. That's 1/10 a percentage of 10 millionth of a percent chance of getting that value. We know that the mean, well, we have one of two possibilities. One is that we got really unlucky and our sample of 35 included the 35 biggest spenders in the company, and we got a very high rate, but that's 1 in 10 billion? 1 in 5.6 billion? I don't think so. Or the other possibility is that our assumption of $500 is incorrect. Chances are that's the real answer, and that the average is going to be something greater than 500. Well, what's the range it could fall into? And that's where we jump forward to problem 8.74, and we want to know the range that the average should fall into. Well, we want 95% confidence. Now, 95% confidence. Let me bring up this. Is this the one I want? Yeah. I'll put it down here. 95% confidence says that 95% of the sample means, if we do this experiment over and over again, excuse me, take 35, sample of 35 many, many times. Each time we do that, the average should fall somewhere within plus or minus 2 standard deviations, 1.96 standard deviations of the mean. So what we want is to have the tail area be tail areas to be 5%. Now we have to divide the 5% into two pieces, one for the left tail, one for the right tail. And because this is a symmetric curve, we can divide it in half. So the area we're really interested in over here is 0.025. Now we've been doing this long enough, so we really know our z alpha over 2 value is going to be what, everyone all together now, 1.96, right? But let's calculate it out. I'm going to use Excel. You can go back to 6.1 if you want. I'm going to do norm standard inverse because I'm going to start with a probability of 0.025 and find the z value, and sure enough it's minus 1.96. Now minus 1.96 is get my picture out here. There it is almost 2, and so the other one, because it's symmetrical, is going to be plus 1.96. So all we have to do to calculate the range, the lower limit is going to be equal to our sample mean of 538 minus 1.96 times our standard deviation, sample standard deviation, 6.76, or 524.75. In the other direction, it's going to be 538 plus 1.96 times our sample standard deviation. So the actual range of average expense reports given a sample size of 35 is going to be between $524 and $551, considerably greater than the 500 that the boss was assuming in the first place. Okay, that's it for chapter 7 and 8. Tune in to video B for chapter 9.